So this video looks at a rule that we use, some in pre-calculus, and for a long time the rule confused me until one day when I was teaching Maclaurin Series in calculus, it just all fell into place and made sense. So the question I had for a long time is, why does e to the I theta equal cosine theta plus I sine theta? And here's the way that we go about it. So first, let's recall a couple Maclaurin series: sine of x, cosine of x, and e to the x. And I just put a video up for this previously, so you can find that video if you want to see why these are what they are. But sine theta is going to equal sort of this: x minus x cubed over 6 plus x to the 5th over 120 minus x to the 7th over 5040, so forth and so on. Cosine is going to be 1 minus x squared over 2 plus x to the 4th over 24 minus x to the 6th over 720, and so forth and so on. And e to the x is going to be 1 plus x squared over 2 plus x cubed over 6, all the way up, so forth and so on. So what we see here is we see that sine takes care of all of the odd powers. Cosine has all the even powers. This is x to the 0. E has all of them: x to 0, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, so forth and so on. The terms, the magnitude of the terms, are always equivalent. So I have 1x. I have x squared over 2, I have x cubed over 6, I have x to the 4th over 24, x to the 5th over 120, x to the 6th over 720, x to the 7th over 5040. But the signs aren't always the same. I have cosine and sine alternate, whereas e to the x is positive all the way through. So how do we wrap this up? And actually, here's what happens. So e to the I theta. Well, using that rule for e to the I theta, I know what this equals: 1 plus I theta plus I theta squared over 2 plus I theta cubed over 6 plus I theta to the 4th over 24 plus I theta to the 5th divided by 120 plus I theta to the 6th over 720 plus I theta to the 7th over 5040, and this keeps on going. And what happens now is this. So I want the odd powers to go to sine. I want the even powers to go to cosine, but I don't have the alternating yet. I actually do. So let's look at sine. So all of these, I have I times theta. And I have plus I cubed theta cubed over 6. I have plus I to the 5th theta to the 5th over 120. I have I to the 7th theta to the 7th over 5040. And that keeps going. And then I have the even powers. I have 1. I have I squared theta squared over 2. I have I to the 4th theta to the 4th over 24. I have I to the 6th theta to the 6th over 720. And here's what happens. If I factor an I out of this blue stuff, I get I times theta. I'll have an I squared left over, and I squared is -1, so I have minus theta cubed over 6 If I factor an I out of this, I will have I to the fourth left over. I to the fourth is positive 1, so plus theta to the fifth over 120. If I factor an I out of this, I'll have I to the sixth. I to the sixth is negative 1, and lo and behold, I get, in here, sine of theta. Over here, I don't need to factor anything out because I squared is negative 1. I get negative theta squared over 2 straight away. I to the fourth is positive 1, so I get plus theta to the fourth over 24. I to the sixth is negative 1, so I get theta to the sixth over 720. And without even factoring anything out, I can see that this is cosine. And so, by using the rule that, so because I squared is negative 1, and I to the fourth is positive 1, and it keeps going that way, I can rewrite this. This right here is just cosine of theta. And this part here is sine theta. But I factored out one I to get all those even powers of I. And so that is why e to the I theta is cosine theta plus I sine theta. Feel free to comment below if you have any questions.